Hello friends, in this video we will write a program in the assembly language of 8051 microcontroller to find the average of n numbers. Okay, we are given a block of n numbers and from those numbers we have to find the average. Now how we find the average? We first get the sum of those numbers and then divide that with the total number present in that block. Okay, so here also we will find the average of the numbers present in a block of n bytes. So let's start with the program. So let us first see the program statement. So we have to write an assembly language program of the 8051, means we will use the instructions from the instruction set of the 8051 microcontroller. Then we will write the program to find the average of block of n bytes, means we are given a block of n numbers. Okay, and we have to find the average of those n numbers. So let's start with it. So first of all, let us see that what are the things which are already given to us. So first, it is given that we are having a block of n bytes. So this block of n bytes is present at the source location. Suppose that, for example, 10 numbers are given to us and these 10 numbers are stored at some memory. Okay, so that memory location, the address of that memory location where the numbers are stored, it is already known to us. Okay, and we also know that how many numbers are present in it. So after that, when we know that there is a block of n bytes, so how many numbers are there means that whether they are 10 numbers, there are 20 numbers, 30 numbers. So count that how many numbers are present in that block. We are having a counter. We will initialize a counter using the register R0 and we will increment this register again and again as we are having every number, as we will see every number. Okay, so initialize the count in the R0 register. Now our task here is to find out that how many numbers are present in that array, because if we want to find the average, then average is find out by the sum of n bytes divided by the number n. Suppose that there are the value of n is 10. Suppose that there are 10 numbers present. So what we will do, we will take the sum of all these 10 numbers and then divide it by 10. Then we will be able to get the average. Okay. Now in starting we don't know that how many numbers are present in the block. So to count that numbers, we are having the counter in the R0 register. Okay, so that we can divide it by n and we can get the average. Now source location, that is the memory address from where all the numbers are stored, all the 10 numbers are stored. Suppose that that memory location is 20h. Okay, from 20, 21, 22, 23 up till 29h, all the 10 numbers are stored. So to point to this memory location also we will require a pointer. So we are using here we suppose that this source address is in register R1. So we are going this R1, that is 20H, from where the numbers are being stored, it is in register R1. We are going to increment this register, so we will get to know that how many numbers are present in it and what are these numbers. Suppose at 20H the first number is stored, at 21H the second number is stored. Okay, so we are having that this source address is in register R1. After that, we want to add these numbers because we have to find out the sum of these n bytes, then only we can get the average. So first number plus second number plus third, fourth, fifth, sixth, in this way all the 10 numbers are added. So next step, we will do the addition. Add the n bytes using add instruction. So byte by byte, all the numbers will be added. First and second number will be added, then their result will be added with the third number, then their result will be added with the fourth number. So byte by byte, two numbers will be added. Now when we have added all the 10 numbers, then the result of that addition will be stored in register A. So in register A, we will be having the sum of the n bytes. Okay. Now sum of n bytes we have got, and this n, that is how many numbers are present in that array, that is in R0 register. So we will shift this R0 register So divide this sum by the number of bytes and then find the average. Okay, because we have got both the values, so just division is to be done and we have got the average. Now when we divide two numbers, the one is our result and then we have got also the remainder also generated. So we will use the result of division, that is quotient and remainder. Two things will be generated. So quotient will be stored in the A register and remainder will be stored in the B register. So the result of the division will be quotient and remainder. Quotient will be stored in A and remainder will be stored in register B. So these are the steps which we will follow, and in this way we are going to find the average. Okay. Now let's draw the flow chart of this program. Now in flowchart, the first step is the start. Every flowchart will begin with the start block. Okay, and this start is shown in an oval shape block. Okay, after that, in the explanation, I have said that our first thing is that the n bytes, they are present at the source location and this source location is in register R1. So first step is to initialize R1 with the source address. So suppose that the numbers are stored from the 20H memory location. So in R1 we have got the number 20H. After that, we will initialize the counter. Because we want to find the average of a block of n bytes. So how many numbers are there in that block, that is also to be initialized. So suppose that there are 10 numbers, so in R0 we will get the value 10. Okay, so initialize this register R0 with the count of the numbers. After that, we have to add the n bytes. Means all the 10 numbers we have to add. Now, how the 10 numbers cannot be added simultaneously, that all the 10 numbers we can get the sum byte by byte, these numbers will be added. So add the n bytes byte by byte. Now suppose that first and the second number they are being added. After that, first and second number they are added, their result we have get. Now third and fourth and fifth, in this way we are having all the 10 numbers. So now this result will be added with third. We will generate that. After again we will generate the result. Again this result will be added with fourth number. Then result will be generated. Then that result will be added with the fifth number. So to get to the next memory location, we have to increment this R1 register. So increment R1 to point to next location. To point next location. Also, when first number is being added, second is added, third is added, so how we will get to know that all the numbers in the array they are being added? We will decrement this count. 10, 9, 8, 7. Now when this counter has reached to 0 value, it means that all the numbers are being added. So next step will be to decrement the count. Now when we are decrementing the count, we will every time we will check that whether the count is 0 or not. Is count equals to 0 or not? If it is 0, then it means that all the numbers are being added and the result of this addition is in the accumulator. So we will initialize a register B with the count. Because in A register we are having the result, that is the sum of n bytes. Now we want to divide it with the total number of present in it, that is 10 numbers are present, so sum is to be divided by 10, then only we will get the average. So we will initialize this B with the count, that is 10. After that we will find the average. How the average will be find out? Sum, which is in accumulator, that is to be divided by the count, which is in the B register. And when this average is being found, then this is the end of the program. So in flowchart we will write the stop. Now here, if the count is not 0, okay, condition can be that count can be 0 or it cannot be 0. If it is 0, then find the average. If it is not 0, then again you have to repeat the process. You have to add the n bytes, you have to increment R1, you have to decrement the count, and byte by byte you have to add all the numbers till the count is 0 and all the numbers are being added. So this is the flowchart for this program. Now to write the program in the assembly language, what we will do, we will replace all the blocks which are present in the flowchart with the instructions. Okay, so with the help of flowchart becomes very easy that what will be the sequence of the instructions, how the instructions will be written, what will be the first step, second step. So in the flowchart we can get the direction of flow of the instructions. So let's write the program for this. Now in the flowchart, our first step is to initialize the R1 register with the source address, and source address is, we have supposed that it is 20H. Okay, so first thing will be to move in the R1 register the immediate data 20H. So R1 register will get the value 20. Immediate data means that whatever data is written here, that will be shifted into the R1, that will be copied. Okay, so immediate data is always represented with this symbol, and this is a type of immediate addressing. Okay, now the second step in the flowchart was to initialize the register R0 with the count of numbers, and we have assumed that there are 10 numbers in that block. So move in R0 register the 10 value, that is 0AH. H always denotes that these numbers are in the hexadecimal notation. If it is in decimal notation, then different will be there, but always the numbers are represented in the hexadecimal notation, so H is written after them. After that, because we want the result, okay, so we have initialized the result in the register B, and we have initialized this as 00. We have given it an initial value. So here only the initialization is being done up till this step. Now after that, the number which is stored at this memory location 20H, the first number, that number is to be shifted in the accumulator, that is A register. Then only we can add the A and the B register, and we can get the result of the first and the second number. So next step will be to move in accumulator the number which is stored at 20H. Now in R1 we are having the address. We don't want this address, but we want the number which is stored at this address. So for that we use the indirect addressing, that the number which is in R1, that is the address, at that address a number is being stored, so put that number in the A register. So in A register we have got the first number. Now after that we will add A and B, because we have initialized this B as the 00. Okay, so when first and the 00 they will be added, so the result will only be the first number. So we have got in the B register as our first number, means when these two numbers are added, the result is still in the accumulator, but we want that this result should be shifted in the B register. So again we will write one step, move B comma A. So our aim is that always the result should be in the B register. But for addition is always performed with the accumulator. So every time the number should be shifted in the accumulator, and then accumulator means these two numbers will be added, and then that result will be shifted in the B register. Okay. So in these steps what we have done, B is initialized as 00. After that the number which is in at R1, that is 20H memory location, that is added with the accumulator. Okay. Then after that accumulator and B, they will be added. In B we are having 00. Then afterwards the result which is in accumulator, that is shifted to the B register. Okay. Now when this is being done, then 20H, that is R1, it has to be incremented so that it can point to the second number. Then 22H, 23H, so that all the 10 numbers they can be added up. So to increment this R1, we will write the instruction INC R1. Okay, that is also in the flowchart when the bytes are being added. After that you have to increment R1 so that it can point to next location. After that you have to decrement the count, and also you have to check that whether it is 0 or not. So for that we will use the instruction decrement and jump if it is not equal to 0. So it is going to decrement the R0 register, also it is going to jump if it is not 0. Now where it is going to jump? If this count is not 0, then you have to again repeat the process. So it will jump to L1, and L1 is here. Again the R1 is moved into the accumulator. Again A and B will be added and the addition process will be repeated. So until and unless all the 10 numbers they are being added, the process will be repeated again and again. Now when all numbers are being added, this R0 has become 0. So next step will be to initialize the B with the count. Now here B is, at that time B is carrying the result, that is the sum of the numbers. So to protect that value, protect that sum of numbers, what we will do, we will move the contents of B again into the accumulator. So earlier the result is in B, now the result, that is sum of the numbers, will come in register A. Okay. Afterwards, we will shift this count value into the B register. The count means that how many numbers are present in the block, and that we have already given in R0 register. So we will move the contents of the R0 register, or we can directly give the value 10 to this B register. We can put here R0 also, we can put here directly the immediate value 10 also. Now sum is in A and the number, that is how many numbers are present in, that is in B. So we have to divide them to find the average. So for division we will use the instruction div A and B. And when these two are divided, then in A we will get the quotient and in B we will get the remainder. So we can check these two registers to find out the average. Okay. So after that, this is the last statement of the program, end. It means that program has terminated. Now no instruction should be executed after it. So this is the program through which we can find out the average of a block of n bytes. Here we have assumed that there are 10 numbers and we want to find out the average of those 10 numbers. Okay, so how we are finding the average? To find the average, we have to divide the sum of those 10 numbers by the 10 value. That is, those 10 numbers should be added and then we should divide it with the value 10. So here first we have initialized a register R1 with the starting memory location where all the 10 numbers are stored. So 20H, the all numbers are stored, all the 10 numbers up till the 29H memory location. Now 10 numbers are there, so that will be loaded in the R0 register. B is used as the initial result, that initial sum of those 10 numbers is 0, 0. Afterwards, the number which is at R1 memory location, that is added with the accumulator. Now A and B, that is initial result, they are being added. Okay, the number which is at first memory location, that is shifted into accumulator. Afterwards it is added with the B register. Then result is there in accumulator, but we want the result in B register, so copy of the contents will be done. Then the R1 register is incremented. Then we have to decrement the R0, that is the count value. So when R0 is decremented, it is going to jump again to L1. If it is not 0, then process will be repeated. If it is 0, then the result is there in the B register. Move that result into accumulator. Put the count in the B register, divide them to find the average, and you will get the average of the numbers. So this is the assembly language program using the instructions of the 8051 microcontroller to find the average of the block of n bytes. So I hope that this program is now clear to you. Thank you.